What's going on, guys? Welcome back to the shop. We're at my welding bench, and as you can see on the table, I have a job. It's for a shop neighbor of mine. So let me show you the part and show you the modifications that need to be done. So here's the part. It's an attachment for a forklift so you can move around a trailer. Like I said, it's for a shop neighbor of mine. I don't have a welding shop where you would walk in and get something like this modified. He just came in and asked me to do it, and he's a good guy and he's got a forklift, so got to keep him in my good graces. And I'm going to do this for him. So basically what happened is he got a new forklift and his forks are now too wide to fit in this opening. The part is made from C-channel. You can see it's a solid piece of C-channel welded to this plate. Now, I'm not going to go ahead and remove this whole thing. We've already had a talk about it. He doesn't do a lot of heavy lifting. You could see it's even got chain hooks on the back. He said he's never even put a chain around it and secured it. So he doesn't do anything heavy and crazy. He moves empty trailers around on concrete in front of his shop. So what I'm going to do is I'm going to modify this existing plate. So let me show you the parts that I'm going to use and the process that I'm going to do. Now, we've already discussed it, and this is an okay modification for him. So I'm going to take this piece of 3/16 angle iron, and he brought some extra chain so that I would be able to put another chain hook on, and we're going to cut straight across here and straight across here. And we're going to remove a small sliver and then be able to take this and weld it over top. And I'm going to position it in a good way so there's a nice beefy fillet weld area to weld to. I'm not going to do any butt welds. We've already measured it out. It looks like it's going to work. So the first step is going to be to cut this apart. So let's get started.
To cut the part up, I'm using an angle grinder with a cutoff disc. I see a lot of people who are afraid of cutoff discs solely based on the stories and pictures they've seen on the internet, but as long as you follow your line and don't side load the disc, you generally shouldn't have any issues. Side loading happens when you put pressure on the side of the disc instead of straight into the cut. This can cause the wheel to flex and in worst cases, completely come apart. The easiest way to avoid it is to let the wheel do the work and keep the grinder moving in line with the cut. I use cheap cutoff discs, and the trick to getting a good cut is to lightly score your line first and then gradually work the cut deeper as you go. On thicker steel like this, you want to avoid burying the disc too early because it could bind up in the cut and put extra stress on the wheel. Taking your time not only helps the disc last longer, but it's also a safer and more controlled way to cut. I won't bore you with showing the second cut, mainly because I forgot to hit record.
And just a few M18 batteries later, and this piece is all cut off. You can see now I'm going to take the 3/16 angle, put it over top. The inside edge of the angle will be to this outside corner here, effectively giving me around 3/4 of an inch more opening width. The biggest thing that's going to be time consuming is, since this is upside down right now, so the fork is going to need to slide against here. I'm going to need to clean all of this weld down. I thought about using a plasma cutter, and that would have been fine for here, but using a plasma cutter down here would have made an absolute mess. It made it even harder for me to clean up. So not much else to do but go ahead and start doing it. So let's get to it.
I started off by using a grinding wheel to cut down the weld, and it worked okay, but it was taking a really long time. I kept thinking about putting it in my milling machine, but that would mean taking off the vise and setting it up on the table, and by the time I got everything set up, I could have already been done, so I just pressed on. Plus, I'd have to consider the time it would take to set the vise back up on the mill, and to me, the juice just wasn't worth the squeeze. You can see here that a lot of material needed to come off to actually grind the weld down. As I got closer to the plate, I switched off to a different grinder and a flap disc, and to be honest, I probably should have used this setup from the start. You can see here that the sheer volume of sparks coming off the wheel is much higher with the flap disc. Now it's a larger wheel on the yellow grinder, and I'm not 100% sure if the two grinders have two different speeds between them, but it's one of those times that it would have helped speed things up by trying a slightly different setup. With half of it done, you can really get a good idea of how much metal actually needed to be removed, and it was a lot. To finish it off, I cleaned up the paint and rust from any areas that I'll need to weld to.
Now you can get the idea of where I'm going with this. Cut the section out. I've got this propped up on this is 3/8, so this is 3/8, and I have it propped up. I just want to be able to put a weld in between these two, kind of a fillet weld to the bottom edge of this and the side edge of that. And then on top, ideally, you see how there's a gap right there? Ideally, I would cut this or this and bevel both and run a stringer all the way down and then grind it, put a plate over top. But in all honesty, one of these things new from Amazon is like 40 bucks. So it's really not worth it for me to put the time in, for him to put the money in. I don't even know if I'm going to charge him for this. I might just ask him to borrow his forklift a few times and we'll call it even. Next step to do is to cut this to length on my bandsaw, prep the edges a little bit, and then we can go forward with tacking it in place.
I used my angle grinder and cutoff wheel to diagonally cut the two corners on one end of the angle iron. I just did this so there wouldn't be any overhang here, and also because the original C-channel had a rounded corner to the plate and I wanted to match it. Again, I'm just taking light passes until I have a line established, and then I'm starting to increase the depth of cut. Then it's over to my 12-inch disc sander to round off the edges. Now is a great time to go ahead and hit that subscribe button if you haven't already. It really helps the channel out, and it also lets me know that you like these types of videos. I put the piece in my horizontal bandsaw and I cut it down to length. Then I took the rust and mill scale off in the areas that I'll be welding to so I could get a nice clean weld. I used that scrap piece of 3/8 plate so I could position the angle iron in exactly the right place, and it would give me a nice channel that I could sink my weld into. A couple of small C-clamps held the angle to the part, and then I used a large C-clamp to set my gap right. Once I was happy with the fit, I went ahead and laid down a few beefy tacks to keep it all in place. Before I did the final welding, I just wanted to double check the fitment. The forklift was in a really weird spot and I didn't want to start it up just to lift the forks, but when I flipped the part over and slid it on as far as I could, it looks like I'll have a solid 1/4 inch of gap between the fork and the inner wall.
Okay, it's up on the welding table and in a position where I think it's going to be comfortable for me to weld. I'm going to go ahead and preheat the whole thing with a propane torch first. I have a 190 amp Hobart. Cranked all the way up, it does good, but I feel like if I do a little propane torch heating, it's going to give me better penetration. This is pretty thick steel. This is 3/8 to 3/16, and I'm not going to run a straight stringer. Normally, if I run a stringer, it gives a good weld, but the profile is a little round on thick steel like this. I seem to get better penetration with my welder, and all welders are different, if I do a little bit of a back step. So I'm going to do a push pass from right to left, and a slight back step. I'm not going to whip. Whipping, I would go from left to right, and it gives a nice looking weld, but I'm more concerned about penetration with this one. So let's get it preheated and get it started.
I cut off a link of chain and I could tell just by looking at it that it was galvanized. Galvanized steel not only welds poorly, but it'll also let off fumes that can make you sick if you weld too much of it without proper ventilation. I just threw a few tacks on it and I do have a fan off camera that keeps the smoke out of my face. There was a big gap at the very end from where I cut it apart earlier, so I just took a small scrap of copper that I have around just for times like this. The weld won't stick to the copper and I could use it as a backer to help me fill this gap. A few licks on the spinning death wheel on this part is pretty much ready to go.
All right, guys, overall, very happy with the way the project turned out. The weld is more than adequate for what he needs it for. Like I said, light duty, moving small trailers around on a concrete surface. I think this will hold up just fine. If you like this video, be sure to subscribe to the channel for more videos just like that. Give a like to the video and keep grinding away on this project. Stay lucid, and I'll see you in the next one.